Okay, this is Math 1, Mr. Trutna from Clovis High School. This is Worksheet 5.4a. These will be the solutions. Okay, so in Worksheet 5.4a, we have word problems, and we're going to be involving word problems that will involve either exponential growth, exponential decay, or compound interest. And you can see that we have the three formulas that we use. And each formula, the variables are identified as to what they would be. So what you're going to do in the problem is, the first thing you do is you read the problem. A population of 53 wild Mustangs increases at an annual rate of 15%. How many Mustangs will there be in 6 years? Okay, so after you read the problem, you want to determine, is this an exponential growth, decay, or a compound interest problem? Now remember, if we're dealing with a compound interest problem, typically, almost always, you will see the word compound or compounded in the compound interest problem. Okay, since I do not see the word compound or compounded anywhere in this word problem, that tells me it is not a compound interest problem, and number one is going to be a growth or a decay exponential problem. Okay, now because we see the word increase, increase tells me this is an exponential growth problem. Okay, so I'm going to use the formula y is equal to A. A is your initial amount times the quantity 1 plus B. B is going to be your growth percentage, and we're going to represent it as a decimal, to the exponent of x, and the exponent of x is going to be how much time we're going to be figuring out what's the time period for the problem. Okay, so all I'm going to do is I'm just going to substitute in the values. A is my initial amount, which is 53. That's what my population started at here. Then I'm going to go quantity 1 plus, and now B is your growth percentage as a decimal. So you can see the population is increasing at an annual rate of 15%. So this right here is going to be your B value, your growth percentage, but you need to change it into a decimal. 15% is 0.15. And then your X variable is going to be the time period. So I want to know how many Mustangs will there be in 6 years, so my X value is going to be 6. So once I set up my expression or my function, now I'm just going to use my calculator and follow the order of operations to solve. So I have to do the parentheses first, 1 plus 0.15, then I raise that to the exponent of 6, and then I multiply that value by 53. And whatever that is, that turns out to be my answer. So you can see I get 122.59. Okay, but since I'm talking about population, how many Mustangs, I'm just going to say 122. So my answer to number 1 is 122. Number 2, if you deposited $2,000 in an account paying 2.5% interest compounded, there's the magic word, annually, how much money will you have in 12 years? Okay, so we see the word compounded. That means this is a compound interest problem. So in number 2, I'm going to use the formula. A, which stands for amount, is equal to P, which is the principal, that's the initial amount you put into the bank or you deposit, times the quantity 1 plus R. You can see R is the annual interest rate as a decimal, and then we're going to multiply it by T, and T stands for the number of times in a year. Okay, so putting this the values in, P, my principal, my initial amount is 2,000. Then I'm going to multiply that times the quantity 1 plus, and this is going to be my interest rate as a decimal. Now 2.5% is already a decimal, but I need to move the decimal 2 spaces to the left. So I would get 0.025. That would be my R value. And then my T value is my time period. So I want to know how much money will you have in 12 years. So my time period is going to be 12, and then I need to figure out how many times is my interest being compounded. Well, it says it's being compounded annually, so that means it's only being annually means it's only being compounded once a year. So that means my total number of times will be 12. 12 times 1. Okay? Once I get this to this part, I'm just going to use my calculator and I'm going to evaluate the expression that I have. And that's going to give me my amount. So I'm going to add up the parentheses first. So 1 plus 0.025. Then I'm going to raise that to the 12th power. And then I'm going to multiply that amount by 2,000. And I get 2,689, and since I'm talking about money, I have to carry it out to the cents, so 0.77. So number 2 would be $2,689.77. Okay? All right, number 3. The population of a city is 27,000 and decreases 2% each year. Predict the population after 7 years. Okay, so I'm trying to determine, is this a growth problem, is this a decay problem, or is this a compound interest problem? We don't see the word compounded, so we know it's not a compound interest problem, but we see the word decrease. So we know that this is going to be an exponential decay problem. So I use the formula y is equal to A, your initial amount, times the quantity, 1 plus b. B is going to be your decay percentage as a decimal to the x power, and x is going to be your time period. Okay, A, my initial amount, is 27,000. I'm going to multiply that by the quantity 1 plus b is my decay percentage as a decimal. So you can see I'm decreasing by 2%. 2% is 0.02, so B value would be 0.02, and then my exponent is going to be my time period, so I'm predicting the population after 7 years. Okay, so once I establish my expression, I just evaluate it. Work out the parentheses first, 1 plus 0.02, then I'm going to raise that to the 7th power, and then I'm going to multiply that by 27,000. And so my population would be 31,014. I don't care about the decimal because I'm talking about population here. So 31,014 would be the population predicting after 7 years. Okay? Number 4, you borrow $8,500 on a credit card at a 11.8% annual interest rate. How much will you owe after 6 years? Okay, now this particular problem right here, we are not talking about, we don't see the word compound in the problem. Okay, however, because we're talking about the annual interest rate, so this gives us a clue that this is a compound interest problem. Okay, so we're going to use the compound interest formula right here. All right, so the formula is A is equal to P, the principal, that's your initial amount, times the quantity, 1 plus R. R is going to be your interest rate as a decimal, and then you're going to raise that to the power of t, and t will be how many times you're going to have the problem compounded over your time period. Okay, so plugging in the values, P, my principal, my initial amount is 8,500. I'm going to multiply that by the quantity, 1 plus R. R is my interest rate, which is 11.8%, but as a decimal. Now that already is a decimal, but I still need to convert it into 0.118. So I'm going to go plus 0.118, and then I'm going to raise it to the time period, which is 6 years. Okay, so my time period here is going to be 6. Now, there's my expression. Now I'm going to follow the order of operations to evaluate it. So my first order of operation is parentheses, 1 plus 0.118. Then my second order of operation is exponents, so raise that to the 6th power. And then my last order of operation in this problem would be multiply by 8,500. So you could see that is $16,598.58. So $16,598.53. Okay? All right, last one. The population of an endangered species today is 20,000, and I think that's a typo. It's not supposed to say dollars. And is decreasing by 7% annually. What will be the population in 2025? Okay, so right here, since we are decreasing, then we know that this is going to be an exponential decay problem. So I'm going to use the formula y is equal to a times the quantity 1 minus b to the power of x. Okay, so when I work this out here, I'm going to plug in my values. A is my initial amount, which is 20,000. That's my population today. And then the quantity is going to be 1 minus, and then b is my decay percentage as a decimal. So here's my decay percentage. 7% as a decimal is 0.07. So my b value is 0.07, and then my x is going to be my time. Okay, so it says the population of the species today. So today is 2019, that's today. I want to know what will be the population in 2025. So that would be 6 years from now. Okay, so my x is going to be 6. There's my population. So there's my expression. Now I'm going to evaluate this expression by following the order of operations. I have to do the parentheses first, so 1 minus 0.07. Then I'm going to raise that to the power of 6. And then I'm going to multiply that value by 20,000. And that would be my predicted population, 12,939. 12,939.